Argand plane and polar representation. We already know that corresponding to each ordered pair of real numbers x, y, we get a unique point in the xy plane and vice versa with reference to a set of mutually perpendicular lines known as the x-axis and the y-axis. The complex number x plus iota y, which corresponds to the ordered pair x, y, can be represented geometrically as the unique point p x, y in the xy plane and vice versa. The plane having a complex number assigned to each of its point is called the complex plane or the Argand plane. In the Argand plane, the modulus of the complex number x plus iota y equals under root of x square plus y square is the distance between the points P x, y and the origin O 0, 0. The x-axis and y-axis in the Argand plane are called respectively the real axis and the imaginary axis. Let us study about argument of a complex number. Argument of a complex number z is defined as the angle theta which it makes with the real axis taken counterclockwise. If z equals x plus iota y, then argument of z, which is equal to theta, is defined by tan inverse of y by x. Let us study a typical complex number in the Argand plane from the angles 0 to 2 pi. Argument of z equals x plus iota y when x is greater than 0 and y is also greater than 0 is shown here. Argument of z equals x plus iota y when x is less than 0 and y is greater than 0 is shown here. Argument of z equals x plus iota y when x is less than 0 and y is also less than 0 is shown here. Argument of z equals x plus iota y when x is greater than 0 and y is less than 0 is shown here. Let us take an example. Find the modulus and argument of each of the following complex numbers. First one is 1 plus iota. Second one is 1 plus 2 iota. Let us see the solution. The first one, let z equals 1 plus iota and let theta be the acute angle given by theta equals tan inverse imaginary part of z over real part of z, which is equal to tan inverse 1, which means theta equals pi by 4. Now, modulus of z equals under root of 1 square plus 1 square, which is equal to under root of 2. Let us see the second part. Let z equals 1 plus 2 iota and let theta be the acute angle given by theta equals tan inverse imaginary part of z by real part of z, which is equal to tan inverse 2. Therefore, the argument is theta equals tan inverse 2. And modulus of this complex number is given by z mod equals under root of 1 square plus 2 square, which is equal to under root of 5. Let us study about the polar form of a complex number. Let OP represent modulus of z and theta represent argument of z, where z is the complex number shown on the graph. Here x will be equal to mod of z into cos theta and y will be equal to mod of z into sin theta. Therefore, z equals mod of z into cos theta plus mod of z into sin theta iota, or we can say that z equals r times cos theta plus iota sin theta, where r equals mod of z and theta equals argument of z. Let us take an example. Find the following complex number in polar format: 1 plus iota. The solution is, let z equals 1 plus iota. Then r equals mod of z, which is equal to under root of 1 square plus 1 square, which is equal to under root of 2. Tan theta will be equal to real part of z by imaginary part of z, which will be equal to 1 by 1, which is equal to 1, or theta is equal to pi by 4. This implies z equals under root 2 into cos pi by 4 plus iota times sin pi by 4. Let us take another example. Represent the complex number z equals 1 plus iota times root 3 in polar format. Let us see the solution. Here, tan theta is equal to under root of 3 by 1. Thus, the complex number could be written in polar form as twice of cos pi by 3 plus iota sin pi by 3. This complex number is also shown on the graph. Let us take another example. Represent the complex number in polar form. Z equals minus 16 by 1 plus iota times root 3. Let us see the solution. The complex number could be written in polar form as 8 times cos 2 pi by 3 plus iota times sin 2 pi by 3. We have shown this complex number on the graph. Detailed solution. The given complex number minus 16 by 1 plus iota times under root of 3 is equal to minus 16 by 1 plus iota times under root 3 into 1 minus iota times under root 3 by 1 minus iota times under root 3. We have just multiplied and divided this complex number by 1 minus iota times under root 3. So we get minus 16 times 1 minus iota times under root of 3 by 1 minus iota times under root of 3 square is equal to minus 16 into 1 minus iota times root 3 by 1 plus 3, which is equal to minus 4 times 1 minus iota times root 3, or minus 4 times iota times 4 root 3. Let minus 4 equals to r cos theta and 4 root 3 equal to r sin theta. By squaring and adding, we get 16 plus 48 equals to r square into cos square theta plus sin square theta, which gives r square equals to 64, because we know that cos square theta plus sin square theta equals to 1. Therefore, r is equal to 8. Hence, cos theta equals to minus 1 by 2 and sin theta is equal to under root of 3 by 2. Therefore, theta equals to pi minus pi by 3, or theta equals 2 pi by 3. Thus, the required polar format is 8 times cos 2 pi by 3 plus iota times sin 2 pi by 3.